Okay. Okay. Good afternoon, all. So, in today's session, we are going to discuss the concept of wall thickness. Okay, how to choose the wall thickness while designing any plastic part. Okay, so before going for the how to choose that thick wall thickness, you should aware about what is the effect of the wall thickness. Okay, it may be a thin wall thickness or it may be a thick wall thickness. And what will be the effect of that wall thickness on the you can say that the properties of that manufactured plastic part. Okay, so we will go through one important points. Before that, we will first understand how the analysis of that wall thickness is done, on which factors we are going to decide that wall thickness. In that, we are going to consider various functional requirements. Functional requirement in the sense for which function you are going to use that manufactured plastic part. Then the manufacturing requirement. In this manufacturing requirement, we will discuss some points related to the means which process we are using to manufacture that particular plastic part. Then it's a structural requirement and some properties of that material which will affect the insulation characteristics and its impact response. So these four five factors are there that you have to consider while doing the analysis of the wall thickness. Okay, functional requirements, manufacturing requirements, and structural requirements, and some characteristics like insulation and its impact resistance. All these you have to study, okay, before determining the wall thickness. Then what will be the effect of that wall thickness, means what kind of defects will be there if you are using very high means thick sections, and what are the benefits are there when you are using the thin sections, that we are going to discuss here. And while discussing this, we will try to focus on which kind of defects will get created when wall thickness is very high or sections are very thick in nature. Okay, and here some design considerations are there, means what will be in this sense, you can say that which will be your correct design and which will be your incorrect design, and how to modify the incorrect designs, that we are going to discuss in this session with some means part designs I have taken here, some poor designed parts and some nicely designed parts. Okay, I have taken that here also. Some design guidelines, one separate slide I have added here for providing the design guidelines for that wall thickness. Okay, now before starting this one by one, and some different modifications, some poor designs, some better designs, what will be the disadvantage of the poor design and what is the advantage of the better design, and then how to modify the wall sections so that they will some defects will get eliminated from that section, that we will see some modification in the designs. I have added some pictures from the books only. Okay, these diagrams I have collected from the book. Okay, some fundamentals of the plastic mold design. This is the book's name, and its author is Sanjay Nayak. Okay, wait, I will check it. Fundamentals of Plastic Mold Design. Professor Sanjay Nayak is the author of this book. This book you have to use for chapters from fourth chapter, fourth, fifth, sixth, seventh, and eighth is not here, I think. From three, four, five, six, seven. For these four chapters, you have to use this book. Okay, please refer this book, Fundamentals of Plastic Mold Design by Sanjay Naik. Okay. From this book only, I have collected these diagrams and I will explain one by one. Okay, how to modify that design, why it is necessary to change that design. Okay, one by one we will go through it, and some modification, how to do the modifications with the help of different designs that we will discuss. Okay, now first we will start with what is the effect of wall thickness. Okay, So first we will consider the for determining the wall thickness. Please refer this points. Point number two: for determining the wall thickness, analysis of the following point is required. In that, first you have to do the functional analysis. Okay, what are the functional requirements of that manufactured plastic parts that you have to study, and according to that you will be able to determine its wall thickness. Okay, in that you have to uh, go through certain points and you have to study these aspects, that is the what will be its structure, then what will be its strength, then its dimensional stability, what will be its weight, then what kind of insulation characteristics are needed there. These are some functional characteristics. Depending on this, you have to choose the plastic material uh, to manufacture that particular plastic part, and its wall thickness you have to determine it depending on the strength required and the weight you want. Okay, then some manufacturing requirements you have to consider here. Some manufacturing requirements, and that you have to consider its which molding process you are going to use. Then what will be the its flow characteristics. Then its flow characteristics setting is nothing but how much time it will take to complete its solidification process. Okay, then ejection, uh, how much time it will take for the ejection, or whether that method is very easy or it will consume some time or some other necessary arrangement, extra arrangement is needed, and whether any kind of extra assembly or some support is needed during this manufacturing process. Okay, these points you have to consider. Then in the structural requirement for this nominal wall design, you can say that minimum wall thickness. Okay, what are the structural requirements? In the structural requirement, you have to check the loading conditions to which that manufactured part will get subjected. After manufacturing that plastic parts, how much load will act on that part, and due to that load, with means which kind of stresses will get produced there, means which kind of stresses, or whether there is any kind of the deflection will occur in the manufactured part. This you have to analyze. Okay, before deciding the nominal wall thickness, you have to this is very important point related to the structural requirement in the sense how much load is going to act on the manufactured plastic part. Okay, and after that, whether there will be means how much stress will get created or any kind of deflection will be there, that you have to study, and according to that you have to decide the minimum wall thickness. Okay, according to that minimum wall thickness, you have to decide, and this will come under the structural requirement. And if suppose you have decided to give the minimum wall thickness and still that part is not providing the required strength. Okay, manufactured part is not providing the required strength, then extra support you can add or extra strength you can add with the help of the ribs or bosses. Okay, that extra arrangement is there, that we will discuss in the means we are having that part, that is a design of bosses, ribs. At that time also I will decide it, but just you have to consider here what is the purpose of giving that extra, you can say that, and these will act as the accessories or extra support. They will provide the strength. Okay, ribs and bosses, they will provide the strength to that particular part, so that they will sustain during the stress created while they are under the loading condition. Then if possible you can do the analysis of the material, and you can choose the material which will provide the better strength. Okay, then and then next point is here the insulation characteristics. Okay, next point which you have to consider is the insulation characteristics. Now As we all know that the plastic materials, okay, they will act as a good insulator. They will act as a good insulator for electrical and heat energy. They are having insulating characteristics. Okay, means they can act as a barriers. They can act as a barriers. Now, this insulating characteristics or this insulation properties depends on the thickness also. Okay, it depends on the thickness also. Whenever you are using more thicker part, it will provide you more insulation. Okay, it will provide you more insulation, and depending on your insulation characteristic needed, you can choose the thickness. Okay. Okay, I will repeat it again. Related to this insulation characteristics of the plastic material, they are very good insulators for you can say that the heat energy or electrical energy. And this insulation characteristics also depends on the thickness. Okay, if you want more insulation characteristics, you can go for the higher range of the thicknesses. Okay, depending on the your need of that insulation characteristics, so you can choose the thin wall section, or you can go for little bit thicker sections also, depending on the need of that insulation characteristics. Then the impact response. Okay, the impact response here, you can say that it is nothing but the impact resistance. Okay, impact resistance is nothing but the amount of energy that particular material can absorb. Okay, without fracture, that particular plastic material will absorb whichever impact energy is there. It will absorb it without breaking or without fracturing. That will be termed as its impact resistance. Okay, now when we are using the means more thick sections, their impact resistance is more. When we are using thin section, their impact resistance is very less. Okay. Similarly, means whenever I have discussed that insulation characteristics also, whenever thin sections are there, they will provide less insulation properties or insulating properties, and if thick sections are there, they will provide you better insulation. In the same way, when you are using thick plastic sections, they will provide you better impact resistance as compared to the thin plastic sections. Okay, depending on your need of or that particular impact resistance needed, you can choose the wall thickness. But you have to take proper care of one point here, that when the larger thickness is there, it will increase the impact resistance. It will increase the impact resistance, but one problem will be there. It will result in you can say that some whenever you are using some thick sections, it will increase the stiffness. Okay, it will increase the stiffness of that particular plastic material. So you have to take proper care of these points while selecting the wall thickness or nominal wall thickness. Okay, so these are the points that you have to take into consideration while selecting or while choosing the wall thickness. Okay, these points we have discussed. Okay, which points you have to take into consideration? Initially, you have to start with the functional requirements, which kind of the structure, and then how much strength is needed, then its weight, insulation. Here also I have mentioned the insulation characteristics, its dimensional stability needed. Then manufacturing requirements you have to take into consideration. Here all the parameters, process parameters you have to take into consideration. Then the structural requirement. In the structural requirement, how much stress that material can carry. Okay, that you have to check. Then yeah, after that you have to check its insulation and impact resistance characteristics. Okay, both these characteristics will depend on whether you are going for thin section or thick section. Okay, and there are certain advantages of thick section, but it may result in some defects, okay, like stiffness or other kinds of defects may be there, that we will discuss after this slide, in the next slide. Okay, now here, okay, now these are very just to refer the first formula here, cooling time. Okay, there is no need to remember the formula, but these are, I think these will get repeated in the numerical part of the seventh chapter. Okay, there we are going to discuss it in brief. Here, just you have to understand the relationship between the cooling time and the wall thickness. Okay, just you have to understand the relationship between cooling time and the wall thickness. Now you can clearly understand here from this equation that cooling time is directly proportional to the square of heaviest wall thickness. Means as the wall thickness increases, cooling time required for that particular material or for that particular part, it increases. Okay, when you are increasing the wall thickness 2 times, then cooling time automatically get increased by 4 times. Okay, if you are increasing the wall thickness by 2 times, cooling time will get increased 4 times. This is the relationship between the cooling time and wall thickness that I have highlighted in the first point here. Theoretically, cooling time is directly proportional to the square of the heaviest part wall thickness, or the power of 1.6 for the largest runner diameter. Here, just concentrate. This is the second formula I have taken here. The second formula. Just you have to take into consideration this first formula. Cooling time is directly proportional to the heaviest wall section. Okay, heaviest wall thickness or heaviest wall section means when the wall thickness is more, it takes more time for cooling. Okay, it will require more time for cooling, and hence whenever you are manufacturing the thick sections, it is very uneconomical. It will take more time. That's why mass production becomes uneconomical, and it may result in the you can say that uneven cooling. It will result in the some kind of the defects also. Some kind of defects may be there due to the uneven cooling. You can say that there may be warpage, or there may be sink marks. There may be warpage, sink marks. These kind of defects will be there when we are using the thick sections. Okay, yeah, that only is explained in these diagrams. Okay, here the this all is related to the issues. There may be issues with non-uniform wall thickness. Okay, when we are using non-uniform wall thickness. Okay, here I have explained that whenever thick sections are there, whenever we are going for thick sections, it takes more time for cooling. Okay, as thick sections are poor conductors of heat, they will take more time, and they shrinks more. Okay, they shrinks more. Hence we have to avoid the thick sections. They will take more time for cooling, and as they are poor conductor of heat, they will take more time for cooling, and they shrinks more. Okay, shrinkage will be more when thick sections are there as compared to the thinner sections. Hence generally we are going for thin sections only. Hence the wall thickness should be minimum. As far as possible, it should be minimum. Okay, when wall thickness is more, it requires more time for cooling, and that process becomes uneconomical. It will take more cost. Okay, hence the sections should be thin. Means wall thickness should be minimum. Wall thickness you have to provide, it should be minimum, and that minimum wall thickness should be uniform throughout. Okay, if wall thickness is non-uniform, okay, here you can see this is the design of the part. Here you can say that some thin section is here at the top side, thin section is there, and at the bottom side, thick section is there. This is the thick section. Here also, this side thin section is there, and this is the thick section. Okay, when we are doing the means uniformity is not there. This is the wall thickness. Okay, here wall thickness is minimum, then wall thickness is you can say that on the higher end or maximum. Here also wall thickness is minimum, and after that this is the maximum wall thickness section or thick section, and this is the thin section. Means non-uniform wall thickness is there. Then what will happen here? Warping will occur. Warping is nothing but instead of end product after doing the molding process, instead of getting this straight product, some you can say that warping is there. Some bending will occur here. Here you will be able to see the some bending is there. Instead of straight product, the bended product is manufactured. Okay, this is termed as the warpage, or some kind of the marks will be there. Okay, sink due to the shrinkage. Shrinkage. Whenever thick sections are there, it will more shrinkage will be there as they are cooling or take more time for cooling. Okay, sink marks will occur. Okay, whenever we are going for thick sections or non-uniform sections are there, some thin and some thick sections are there, means uniformity is not there in the wall thickness, then warpage, this is the warping, and these are the sink marks. These two defects may occur. Okay, warping and sink marks will be there. Then why this warping or why this sink mark is occurring here? Okay, as already we have discussed that thick sections cool slower than the thin sections. Okay, whenever here this is the thin section and this is the thick section. Thick section will require more time for cooling and thin section will require less time. Means thin section solidifies first, and thin section is it will require more time for full solidification. And as thin okay, thick section cools. Okay, first solidification of this thin section will get completed, and solidification of thick section is going on. And what will happen here? Thick section it shrinks. Okay, this thick section it shrinks, and here what will happen? The material, okay, material will come from, you can go through here, what will happen here? Material from the, you can say that unsolidified area which are connected to the already solidified thin sections, it will flow, and this builds the stresses near the boundary of the thin section to the thick section, and it will result in this warpage. You can go through this diagram here also. Okay, this warpage will occur. In short, you can say that the material from this section, okay, it will flow towards these corners. Okay, more material will flow towards this side. That's why here less material will be available, hence warping will occur. Hence warping will occur. Material will flow as thin section solidifies first. Material will flow towards that side only. Okay, it will flow towards the thinner side, as on this side material has already solidified. Hence material will flow in this direction. Hence warping will occur here. This is the warping, and these are the sink marks. Okay, these are the sink marks, and the sink marks. Why these sink marks will occur? When suppose this is the thin section, then it will get solidified first, and it will means you can say that attract the material from the thicker sections. Hence, some sink or a shrink will occur here. Okay, it will get sinked from the other side. As this is the thin section, it will solidify first, and it will the material from thick sections it will flow towards the thinner section. The same way as this warpage has occurred. Okay, thin section will solidify first, and as more material is there on the thicker side, this material will flow towards this solidified part. Okay, this will solidify first. This material will flow to in this direction. That's why warpage will occur. In the same way, sink will occur. Sink marks. Thin section solidifies first, and material from thicker sections will flow towards the thinner section or solidified part. Hence, it will result in warpage or sink marks. Okay, to avoid this warping or sink marks, the wall thickness should be minimum and it should be uniform throughout. It should be uniform throughout. If wall thickness is non-uniform, then warping will may occur or sink mark may occur. Okay. So that's why you have to select the minimum wall thickness. Why to select minimum wall thickness? Then you have to explain with the reference to this equation. Cooling time is directly proportional to square of heaviest wall thickness of the part. Means as wall thickness increases, cooling time will increase, and it will increase the cost of that process, and mass production becomes uneconomical. Hence, we have to go for minimum wall thickness, and that should be uniform. When unequal wall thicknesses are there or non-uniform wall thicknesses are there, then a thin section will solidify first, and material from thicker sections will flow towards the thin sections. Hence, warpage of the component or some sink marks may occur as material will flow towards the thin section. Okay, so these are two defects. For avoiding this, uniform wall thickness should be selected. Okay, now how the means while designing the parts, which points you have to take into consideration. Some design considerations related to the minimum wall thickness that we will discuss now. If you are having any difficulty, you can ask me. I'll wait for few seconds here. If you are having any difficulty, you can ask me by unmuting yourself, or you can put the queries in the chat box. Okay. Now we will discuss some points, some design consideration or design guidelines while deciding the wall thickness. Okay, design guidelines for the wall thickness. Now, basically, you have to start with the material selection. Okay. Now, what is the effect of the material selection on the wall thickness? For that, you have to understand this is one typical, you can say that one flow curve or spiral flow curve for some materials I have collected here. some nylon, polyester, and then acetyl copolymer and PBT. If you are not able to remember the materials, at least you have to draw the diagram, and you can mention that nylon for number one. This is the according to the numbers I have written the names here. For number one means nylon, number two for polyester, number three for acetyl copolymer, number four for PBT material. Okay. Now, uh, why it is necessary to go through this flow curve? Depending on this flow curve, you will be able to understand the flow, how much flow length that material will provide. Okay, means it will give you the measure of how far one can expect that that plastic material will flow in that mold cavity or through that gate into the mold cavity. Okay, whichever material you are going to select, depending on this flow length. Okay, this is injection pressure and the flow length. How much pressure is required to achieve the flow length required? Okay, depending on this curve only, you can choose the material. Okay, if flow is good, okay, if flow is good, that material you have to select. If flow is good, that material you have to select. Here you can easily understand that this nylon material will give you better flow, highest flow length with the minimum pressure values. Okay, you have to select the material which will give you the better, highest, or more flow length with minimum pressure values. Here nylon is the best one. Okay, in this way, first you have to go through the flow curves of that material so that you can understand how much flow length that particular material will provide when it enters in the mold cavity through the gate and runner arrangement. Okay, while performing your molding process, this first point you have to take into consideration. Okay, and after this, some analysis is there, or what kind of the defects may occur when, or why we are going for the modifications. Some examples I have collected, and this is first at the top side, the poor design or design which will result in the defects that is shown, and how it should be modified. Okay, how it should be modified, that is shown here. Okay, here you can see that some means uniformity is not here. In this slide you can see the on this top diagram, this is the section, and it is it's you can say that wall thickness is there. Okay, here minimum wall thickness is there, and here some at some portion maximum wall thickness is there. In short, you can say that the wall thickness is non-uniform. Okay, at this corners it is thick, and the at the center part it is thin. Okay, what will happen here means it will result in the warpage and sink marks. Already we have discussed this, warpage and sink marks. Why this will occur? Thin section will get cooled, solidified first, and material will flow towards that thinner sections. That's why warpage and sink marks will be there. Okay, to avoid this, you have to modify this design into better one, and this is the better one shown in the second diagram. You have to provide the uniform wall thickness. Okay, uniformity, you have changed the wall thickness, and that thick sections are converted into thinner sections. Okay, thin sections. In this way thin sections are provided. And one more modification is there, instead of providing this sharp corners. Okay, here radius is given. Okay, radius is given, radius or some corners are given with the some radius. Okay, instead of sharp corners, radius is provided. Due to the sharp corners, what will happen? Stress will get created. Okay, these are the stress points that you have to eliminate by providing the radius. This part will again get repeated in the radius or corners, design of corners or radius. Why we are providing that radius or corners, that will get repeated, just because they will create the more stress points. Whenever sharp edges or corners are there, stresses will be more at that point. Okay, and whenever thick sections are there, warpage and sink marks are there, to avoid this, uniform wall thickness should be provided. This is the better design. Okay, in the next design, this is the next design. Okay, now there is another thumb rule. Okay, now this one is the another design of the product. Okay, this is not good, and this is the better one. Okay, and why it is better on in this, this already I think I have added one extra slide here also. Yes, same diagram is here. Okay, this is not recommended. Why it is not recommended? um, okay, some stresses may get whenever we are having this corners. Okay, same diagram is there, you can refer this diagram and this diagram, or if it is better visible, then you can understand here only. Okay, here you can see that due to this sharp corners, some sharp corners are there. Okay, due to that, what will happen, more stress points will be there. Stress points will be there, which may result in the cracking also. The stress points are there, which may result in the cracking. Hence, instead of providing these sharp edges, the wall thickness is gradually decreased. Instead of decreasing it suddenly, whenever you are decreasing the wall thickness suddenly, sharp edges, okay, some sharp change will be there, and due to this, stresses will be more at these corners. Hence, instead of providing the these sharp edges, gradually you have to decrease by providing the radius at the corners. Some radius is provided, and gradually you have to decrease the wall thickness. Instead of decreasing it suddenly, it will result in the more stress. Okay, and that stress will result in the formation of cracks. To avoid that, wall thickness is gradually decreased. Slowly you have to decrease it by providing the radius at the corners. Okay, so in this way, instead of designing your plastic part in this way, you have to go for the better design by providing the gradual decrease in the wall thickness to reduce the stresses, and which may give you the cracking of that parts. To avoid that, gradual decrease in the wall thickness is provided. Okay, then next point, these are some variations in the wall thicknesses. Okay, whenever you are designing, suppose here again, whenever you are manufacturing some handles and knobs of the plastics, handles and knobs, then instead of giving the uneven thicknesses, okay, here you can see that this is the more thick part, and here thickness is less. Okay, thickness is less here. When you, this is not recommended. This kind of design is not recommended, because it may result, as here sharp corners are there, it may result in the more stress. Then thick sections and thin sections are there, means due to this non-uniformity, warpage may be there, or sink marks may be there. To avoid this, okay, to avoid this, these designs are not recommended. Instead of this, you have to modify it in this way by providing the uniform thickness throughout the part. Uniform thickness, if possible, provide uniform thickness throughout the part. Okay, in this way, for designing the knobs and designing the handles, plastic knobs, plastic handles, get that door handles and knobs are there. In this way these are designed. Okay, in this way we are going to redesign the that plastic product by providing the uniform thickness. Okay, here also you have to modify it by providing the uniform thickness. In this way it is modified. Instead of manufacturing it in this way, go for the second design. Okay, then instead of manufacturing the solid part, instead of manufacturing the solid part, you have to go for the hollow components with the minimum thickness. Okay, it will result in means it will reduce the weight of that product also. It will reduce the weights. Okay, in this way you have to go for the better. Instead of manufacturing the thick and heavy sections, you have to go for the thin and lighter weight sections. Okay, this is the better design. Okay, these are some modifications that you have to do to avoid the. Okay, so extra thickness, this is the undesirable. Here you can see that these are here thickness is small and here thickness is very large. Try to convert it into uniform thickness part. In this way it is modified. Okay, instead of manufacturing this kind of part, you can go for this one. Yeah, just modification is done. Modification is done there. Okay, here also instead of manufacturing this kind of part, you can go for the minimum thicknesses. Okay, instead of same part is you can say that this is the same, this is single part, and you can modify it with different design. This is the first design. Okay, by changing the thickness of the heaviest or highest thickness part to the equal to the minimum one. Okay, uniform thickness, you can go for this one, or you can go for this design also, or you can go for this design. Okay, instead of this larger thick portion, here they have provided the hollow part at the top surface. You can go for this one also, or this hollow part, this solid part can be converted into small that you can say that some kind of the hat sections that I have highlighted here. Okay, so this is the single part. You can modify it in the different ways. You can go for this design, means whichever thick portion is there, try to convert it into the thinner section. Okay, so that there should be uniformity in the wall thickness. Okay, to avoid the warpage, or to avoid that stink marks, to avoid the cracking that may occur. Okay, in this way this part can be modified in different ways. Some three designs they have made here. Okay, and to do this modification you can go for different shapes. Okay, the shapes I have collected some different shapes here. Okay, you can, to make the part more thin, that particular section more thin, or that part more thin, you can go for this hat like section, or corrugation section. Okay, or this is the crowing. Okay, crowing, or this is dome shape. Then bidirectional corrugation. Okay, same corrugation. Nowadays these types of that sheets we are using. Okay, some corrugation is provided. Okay, to give the uniform wall thickness, different kinds of the sections can be improved or modified. That structures can be modified with the different shapes, like hat section, or you can go for corrugation, bidirectional corrugation, crowing, doming. Okay, or some metal reinforcements may be there. Okay, two different sections are manufactured and they are joined. Okay, okay, so how these are the points how design should be modified. Design guidelines are there to modify the design. Okay, this already I have explained. Okay, maintain uniform wall thickness. Why maintenance of uniform wall thickness is required? Okay, wherever possible, maintain uniform wall thickness because it will reduce the risk of sink marks, then induced stresses, and different shrinkages. Already I have explained this. And whichever corners are there, instead of that, instead of sharp corners, radius or fillets are provided. Okay, and generally this radius, whichever radius we are providing, it is 50% to 70% of the minimum wall thickness. Okay, that we are going to study in brief in the that design of the radius part or design of the corner part. But here you can remember that whenever you are providing this radius, okay, this is the radius, instead of sharp edges, a radius is provided, and that radius is 50% or 70% of the wall thickness. Okay, so these are some again modified designs. Okay, some good designs and some poor designs I have collected here. Instead of manufacturing the thick sections, okay, this is the thinner part and this is the thick section. Instead of manufacturing this, you should go for the modification here. Okay, go for modification. Whenever that component is having some thick portions and thin portions, try to convert it into more uniform thickness part. Okay, in this way, these are some wrong designs. You can modify it in the good designs in this way. Okay, in this way, these are modified. And in the second way, if the design limitations makes it impossible to have uniform wall thickness, okay, uniform wall thickness is not possible, then change in the thickness should be gradual. As far as possible, it should be gradual. It should be gradual change. Instead of sudden change, give it a gradual change in the thickness in this way. You can go for a taper also. Go for direct taper, or you can provide the gradual decrease with a radius at the corners. Okay, these are the correct designs, and this is the incorrect design. In this way, you have to modify it. Now, I will summarize this session related to this wall thickness. Now, the minimum wall thickness by doing this analysis. Okay, basic rule for the plastic part design is, as far as possible, wall thickness should be kept less or minimum with it should be uniform throughout the part. Okay, large wall thickness for solid part will affect the economy of the mass production as it takes more time. And when thick sections are there, that thick sections are poor conductors of heat, and they shrinks faster than as compared to the thinner section, which results in the warpage and sink marks. Okay, these are the effects, and to avoid this, wall thickness should be minimum and it should be uniform throughout. And generally wall thickness used for designing the plastic parts, it is in the range 0.1 millimeter to 5 millimeter. Okay, it should be in the range 0.1 millimeter to the 5 millimeter. Okay, whenever we are designing the part with minimum wall thickness, you will be able to do the faster cooling, and you will be able to reduce the weight of the manufactured part, and productivity will automatically gets improved. Okay, so in this way, this is the concept of the minimum wall thickness. This is a very important concept or a very basic requirement for designing any plastic part. You have to decide the minimum wall thickness. Okay, in this way, we have completed this minimum wall thickness concept of, or how to choose the minimum wall thickness while designing a plastic part. This part we have completed here. Okay, in the next section we will go for some design guidelines related to the ribs, corners, scorings, like that. Okay, in this session, we have completed this concept of minimum wall thickness, or how to choose the minimum wall thickness while designing a plastic part. If you are having any query, you can put that in the chat box. Otherwise, I will stop here. Okay, in the next session, we will discuss the allowances and tolerances and design of ribs, design of corners, design of undercuts, then inserts that we will discuss in the next session. Those who have joined late, you can put your roll number in the chat box for the attendance purpose. Thank you for attending this session. Thank you very much.